Hi friends and viewers, welcome to our physical science class. How are you? Yeah, I hope all of you are fine. Now today we are going to learn about more about acids and bases. So in this class, so I hope you are watching all my videos, and today we are going to learn something new. So let's start our class today, acids, bases and salts part 7. So here till now we have learnt about some chemical properties of acids and bases. Acids react with metal, produce hydrogen gas. Even bases also produce hydrogen gas. And also we have seen reaction of acids with carbonates and metal hydrogen carbonates, and also we have seen reaction of acids with metal oxides and reaction of bases with non-metal oxides, and also we learned about neutralization reaction, right? So all these properties we have been learning in since the class we have started, right? Now today we are going to learn about the strength of acid or base. So here how to decide how to decide the strength of acid or base, means whether acid is strong or weak or base is strong or weak. So how can we decide? So it depends on the activity. Already we have learnt, that is acid solution in water conducts electricity, or we have learnt the acids or bases in aqueous solution produce ions. They produce ions which are responsible for the flow of electricity. Do you remember this activity in the previous class we have learnt? Yes. Now to understand the strength of acid or base, we have to conduct this activity again, but by taking different acids and bases. Like, so first we have to take two beakers. In one of the beakers we have to take dilute HCl, that is dilute hydrochloric acid, and in other beaker we have to take dilute acetic acid. So in both of the beakers we have to arrange such arrangement, means we have to arrange two graphite rods which are immersed in the solution, and these are connected to 230 volts AC plug, and in between a bulb is connected. Okay, in both of the beakers, means that is in dilute hydrochloric acid solution, in dilute acetic acid solution. So here when this mains is plugged on, we will see that in both of the solutions, in both of the beakers, the bulb glows. But here the beaker in which dilute hydrochloric acid is taken, in that solution the bulb glows with more brightness, whereas in the beaker we taken acetic acid, in that solution the bulb glows with less intensity. So in dilute hydrochloric acid solution the bulb glows with more brightness, whereas in acetic acid solution the brightness of the bulb is less. What does it mean? It means that there are more charged particles, means there are more ions produced in dilute hydrochloric acid solution, whereas there are less ions in acetic acid solution. So the brightness of the bulb indicates the more number of ions. So here the ions means which type of ions? We have already learned that acids produce hydronium ions, that is H3O plus. Acids produce hydronium ions, H3O plus, or we can say H plus ions, right? So these are responsible for the flow of electricity. Even negative ions also present, right? So here if more number of H3O plus ions are there, then the brightness will be more. That decides the strength of the acid. So hence, as dilute hydrochloric acid produce more H3O plus ions, we say this is strong acid, whereas acetic acid, dilute acetic acid produce fewer number of H3O plus ions, hence we can consider this as weak acid. Got it? So it means that we decide the strength of the acid or base depending on the production of ions when they dissolve in water, or when they produce more number of ions in aqueous solutions, we say that is strong. If it produces fewer number of ions, then that is weak. Got it? Right. So now we have decided a strong acid and weak acid. Here I write. So here we decided this is strong, whereas this is weak. Right? Now, how can we decide a base is weak or strong? Simple. As we have conducted, we have understand the activity by taking dilute hydrochloric acid and dilute acetic acid. In place of these, we have to take two beakers, in which in one of the beaker we have to take dilute NaOH, which is sodium hydroxide solution, aqueous solution. In another beaker we have to take dilute NH4OH, ammonium hydroxide. So if we pass electricity in both of the beakers, we see that in the beaker where we have taken NaOH aqueous solution, there in that the bulb glows with more brightness compared to the beaker in which we have taken ammonium hydroxide. It means that the beaker in which NaOH is taken produce more ions. But which ions? Here we have learned that bases produce what ions? OH minus ions, hydroxyl ions. So here, if a base produce more number of OH minus ions, that is strong, and if the base which produce fewer number of OH ions, that is weak. Right? So like this we can decide the strength of the acid or a base. Right? Do you understand? Right. Now here another way is also there to decide whether an acid is strong or weak. Same for the base also. We can decide whether a base is strong or weak by using universal indicators. Here universal indicator is a solution which is a mixture of several indicators. It is a solution of several indicators which show different colors in different acids and bases depending on their strengths. I'll show you universal indicator here. This is the universal indicator pH paper. This is a litmus paper which we say universal indicator paper. Here it shows different colors. Here it shows different colors in different acids and bases depending on their strengths. So for example, here I am taking three solutions. One is acid, a base and neutral solution. Let us see what is the color of this paper, this universal indicator pH paper in different acid and base solution. Okay. Now here first, here I am taking an acid solution, dilute hydrochloric acid solution. Let us see what color it changes. Okay, what color the change comes. Now I am dipping here. You see here what is going on over here in this test tube. See, the color is changed to red. Right? This is dark red. Right? So in acid it shows a red color. The universal indicator paper, litmus paper, shows a red color. Okay. Now let us see in base. Now I have taken a fresh universal indicator paper, litmus paper, and dipping in base. Let us see what color to it changes. So here you can see which color is this? Yes, blue color, dark blue color, right? So it means that universal indicator litmus paper shows dark blue color in base, in base solution, right? So in base solution, universal indicator litmus paper shows dark blue color. Here we take another solution. Just now we have taken a base and acid solutions, right? Now this different solution which is neither acid nor base. Say it is little bit depending on the color, we decide what this solution is. You see, this is the color light greenish color, right? Here we have a scale. Here this is the color indication papers, so which is called actual pH paper. Now in the next class we are going to learn about this pH. So here it shows near to 6 or 7, this is the number. So here this is called pH scale. In the next session I'll explain about this, but you see the color, right? So here we have got different colors that I want to say about this litmus paper, universal indicator litmus paper. It shows different colors in different solutions. Got it? Yes. Now we have a solution. Just now I said no, universal indicator solution. Here universal indicator, which is a solution, it is the mixture of different or several indicators. Let us see the color, which color we get when we add to acid, base and a neutral solution. Now I'll show you just right. So this is acid, dilute hydrochloric acid. Now I'm adding a drop. So as we have seen on earlier classes, the color is changed to red. The universal indicator changed the dilute hydrochloric acid solution to red color. It changed the color of dilute hydrochloric acid to red color, right? Yes. Now let us take a base solution. This is a base solution, basic solution, right? Now this is nothing but sodium carbonate solution, aqueous solution or dilute sodium carbonate solution, to which I am adding the universal indicator. You can see, yes, dark blue color, even blue to violet color, right? So this is the color. This is the color. In base, when we add universal indicator to base, so dark blue color or violet color is obtained, right? For the neutral solution here, see this is dark, we say this is light blue color. So light blue color or greenish blue color near neither to acid neither to base, means it is in between acid and base. We can say it is a neutral solution. But here we have to understand so here universal indicator shows different colors. Universal indicator shows different colors in different solutions depending on their strengths. Say acid, neutral, little bit neutral, and this is base. Are you able to see the colors? Yes. Do you understand? Right. Yes friends, we have seen different colors produced by universal indicator in different solutions depending on their strengths. So even we can take different acids like sulfuric acid, nitric acid and different acids. By taking them we can test them by or with the help of universal indicator. So from that we can decide which is strong and weak also, right? Like this we can say the strength of the acid or base depending on their production of ions. Now can we define which is strong acid, weak acid, and strong base and weak base? Can you define, or can you say? Yes, let us say. Here, yes, the acid which produce more number of H3O plus ions in aqueous solution is called strong acid, right? Now the weak acid, here the acid which produce fewer number of H3O plus ions in aqueous solution is called weak acid. Now I think you can define strong base and weak base. So let us see here, the base which produce more number of OH minus ions in aqueous solution is called strong base, right? Now the base which produce fewer number of OH minus ions in aqueous solution is called weak base, right? So these are strong base, strong acid, weak acid, and strong base, weak base. So this is about strength of acids or base.